Welcome to the Reinheimer Quiz 5 Answer Hour. Actually, it's 15 minutes. We're going to go through questions 1 through 5. So, jump on this crazy train. Strap your seatbelts. And let's go for a ride. Alright. Let's go ahead and start off with problem number 1. We got to divide 6x to the fourth plus 5x to the third plus 3x minus 5 by 3x squared minus 2x. So we first got to set it up, right? Okay, so here we have it set up, and the thing that you should take note of is that I added a 0 times x to the second as a placeholder. And first thing we're going to ask ourselves is what times 3x squared is going to give us a 6x to the fourth power? And 2x squared times 3x squared will give us a 6x to the fourth power. So let's go ahead over here and go 2x squared in the quotient spot. And 2x squared times 3x squared, we got a 6x to the fourth. And then 2x squared times a minus 2x, we got a minus 4x to the third power. And we have to subtract, and so the 6x to the fourth minus 6x to the fourth crosses off. Negative and a negative is going to give us a positive there, and so we have a 9x to the third. We drop down our placeholder here, and we ask ourselves, what times 3x squared is going to give us a 9x to the third? And that is a 3x. So we have a 9x to the third minus a 6x squared. And we subtract. And we end up with a 7x power 2 plus 3x. And we say what times 3x squared? Oh, why did I do 7x? I was thinking about my answer. Sorry, guys. So we have a what times 3x squared is going to give us a 6x squared, and that's going to be a 2. So we have a plus 2 there, and we now have a 6x squared minus 4x, and we subtract, and that's going to give us a 7x minus 5. And now we're done with the division part. We got a remainder. We can't fit an x squared within an x, so we know we're done. We're at the end of the line here too, so we're done. We got to write our answer in fraction form and also write a summary statement using the division algorithm. Okay, so here we have our division algorithm where we have the quotient times the divisor plus the remainder is equal to the dividend. That's the division algorithm. And we also have our fraction form, which says the quotient plus the remainder over the divisor is equal to the dividend as well. So let's move on to the next problem here. We want to find the cubic function in standard form with the given table of values. So we have when x is 0, y is when x is 1, y is 0, that gives us an x-intercept. Here's another x-intercept, and here's another x-intercept. So that tells us certain factors that we can have. Because we have an intercept at 1, we know that x minus 1 is a factor. And we know that x minus 3 is a factor, and x minus 4 is also a factor. And this is giving us part of f of x. The thing that we don't know is if we have some a value here which could either stretch or shrink our function. And the a value is found by this point here. We have an x value of 5 and a y value of 16. So what we got to do is plug in the 5 and the 16 and solve for a. Okay, so we have the 16 and the 5 plugged in. Now it's just a process of simplifying and solving for a. So we have 16 equals a times 5 minus 1 times 5 minus 3 times 5 minus 4, and that gives us an 8. So if we divide both sides by 8, we end up with a equals 2. Alright, so we know a is equal to 2, which brings us back to here. We have to multiply everything together. We have an a value up front, and we have to put this in standard form. This is where some of you guys miss points. We have to put it in standard form, so we have to multiply together. Let's go ahead and do so. I'm going to distribute it in the 2, and I'm going to multiply x minus 3 times x minus 4. And let's see here. We'll start off with 2x times x squared is going to give us a 2x to the third. 2x times minus 7x is a minus 14x to the second. 2x times 12, we have a 24x. And then let's multiply the negative 2. Minus 2 times x squared is going to give us a minus 2x squared. A minus 2 times a minus 17 is a, minus 2 times minus 7 is a plus 14. And then we have a minus 2 times 12 is a minus 24. Now I'm going to add straight down, and that's going to give me f of x, which is equal to, we have 2x to the third minus 16x squared plus 38x minus 24. You might be curious, how can we check? How can we make sure that what we found is actually right? One way to do so is on the calculator. So if you plug in your function into y equals and hit graph, you see a graph there that goes through at a 1, a 2, and we have a 3 right there. And we know that that's what our zeros were, so I'm feeling pretty confident about this one so far. Okay, let's move on to the next problem. We want to list all of our possible rational zeros and find all the real zeros of the function. So that means that we're going to list all of our factors of 4 and divide them by our factors of 3 to get a list of our possible rational zeros. So here we have our possible rational zeros all down below here. And it would be very difficult to have to go through all of these and synthetically divide with all of them. It's a big pain in the butt. It's not worth our time. So we're going to use our calculator to use our possible rational zeros and figure out which ones are a reality. Okay, so let's go and jump to our calculator. So here I've plugged in my function, and now if I hit graph, I got my graph there, and it might be kind of difficult for you guys to see which possibilities are the ones we should work with. So I would do either a zoom box or a zoom, or just adjust the window. I'll do zoom box right now. So the box allows us to zero in on a particular area and zoom in to identify what's going on a little bit more closely. So let's go ahead and do so right now. Alright, so there's our graph. Looks like I have a 0 at negative 1. It looks like another 0 is at positive 2/3. How can I be certain of that? Well, before I start synthetically dividing, I'm going to hit second trace on my calculator, go to value 1, and then I'm going to plug in a negative 1, and whoa, that is a 0. That's pretty good. Okay, so I'm going to also test things out with 2/3. So plug in 2/3. And yes, negative 1 and 2/3 are zeros. And that's all I'm going to deal with right now. Because once I whittle it down with those two values, I'm going to be able to factor whatever I have, because I'll have power 2. You guys will see in just a second. So I have synthetically divided with the minus 1, and I got a remainder of 0. So I know that that is the right value, even though we already knew it was. At this point, I can synthetically divide one more time with 2/3, or I could actually factor. What I'm noticing right here is this is a factoring by grouping problem. So I've rewritten f of x and I noticed that for my factoring by grouping, I could pull out an x squared from the first two terms, and I could pull out a -3 from my last two terms, and that gives me two of the same binomial. Oops, two of the same binomial. So we have a 3x minus 2 and a 3x minus 2 here. Oops, what am I saying, guys? I could pull out a 2. Alright, so I do have the same factors. Factoring by grouping is going to give me, we have a 3x minus 2 times x squared minus 2. And so from here I need to set my factors equal to 0 and solve for x, right? So I know that I have a 1, 0 at x equals minus 1, another one at 2 over 3, we knew that one, and the last one here we have to set this equal to 0 and solve the last factor, and we end up pulling the 2 on the other side, gives us a plus 2, take the square root, we end up with plus and minus the square root of 2. And that's irrational. That's why we didn't see it in our possibilities. So here are our zeros. And let's move on to the next problem here. We're running low on time. Oh goodness, this is going to take a while. Okay everyone, so first thing I did is I expanded. So we have 3 binomials multiplied, and we have to start off by multiplying just 2 of them together. And so I have that process right here. And first thing, I got a 3 over 4 and plus 1/4 I squared. That's a minus 1/4 because I squared is -1. So that's going to give me a minus 2 over 4, and then root 3 over 4i plus root 3 over 4i is a 2 root 3 over 4i. And we still have to multiply times the last one. We're going to simplify and multiply. And let me take a time out here real quick and simplify some things. Okay guys, so first let me take the time to say I made that a minus instead of a plus for some reason. So that is a plus, and I simplified my fractions from 2/4 to 1/2. 2 over 4 to 1/2. And so I multiplied my remaining 2 binomials together, and I end up with this expression down here in red. And first thing I see is I got 2 guys that are going to cross each other off, and then I got these two. 1 plus a 3 is a 4 over a 4, which just leaves us with an I. So that's our answer there. Alright, so let's move on to this last problem, last but not least. Actually, it was probably the easiest one. We have to write the complex number in standard form. So we're going to multiply by the conjugate of the denominator. And so that means that we're going to multiply numerator and denominator by 1 plus 2i. That's going to give us a real number in the denominator, which will enable us to put this in standard form. Alright, so a 1 times a 1, we're going to have a plus 4, okay? I'm going kind of fast here, I know. So we multiply 3 times a 1, it's 3. 3 times 2i is a 6i. And then I times 1, and then I times 2i. And so let's simplify. We have a minus 2 there, so that's a 1 plus 7i all over 5. And then we can break up into standard form. So we have 1 over 5 plus 7i over 5. And that is our standard form. It's been awesome for me. I hope it's been just as awesome for you. Let's go ahead and turn off the computer now, because there's only so much craziness I can handle. And I'm going to see you in class. and I'm looking forward to it.